Hey everyone! Thank you so much for watching another episode of the Weaviate Podcast. We have another super exciting one. Box has been trailblazing cloud content management for 2 decades, and today we'll dive into how they're thinking about the new wave of agents and AI native software. Firstly, I'm super excited to be co-hosting this podcast with Weaviate co-founder Bob Van Lout. Bob, thank you so much for joining.
Oh man, it's great to be back. This is always fun. I always look forward to these. So it's great to be back.
Awesome. And I'm also super excited to welcome the CTO of Box, Ben Cuss. Ben, thank you so much for joining.
Thanks for having me on.
So I know, Ben, I know you from mostly from like drinks here and there in San Francisco. And then always when we have conversations, it's always fun. So I look forward to this, but there's this question that I have because if we just talk out loud about like Box as a whole, right? So how big is that? How many documents or the scale or petabytes, whatever number you use, how big is it?
Yeah. So in general, so Box, as you mentioned, so we're the unstructured content store for many enterprises, right? So we have over 120,000 enterprise customers, tens of millions of users. And so the scale by which we sort of operate on is measured in the sort of exabyte range. And so in addition to the there's hundreds of billions to trillions of these kind of fundamental objects, documents, images, videos, and so on inside a box. So this is one of the challenges of something like enterprise class unstructured content is that not only is it big, but it grows tremendously. And it's something that for Box we've been handling for many years. I think since I've got to Box, which was about 10 years ago, I think we've doubled, I don't know, like 9 times or 10 times in that process. And so that is kind of the world that we live in, which is just an exponential growth, as you see in many types of like storage oriented or sort of content oriented internet style, like large data structure, large infrastructure type use cases. And it's just kind of what we live with.
Yeah. And from an infrastructure perspective, right? So if you I like to visualize this world of Box as like Google Maps. So you can have like the whole Earth. So that's basically everything, and there's like data coming in and that kind of stuff. That comes with infrastructure challenges, but you can also like zoom in all the way to street level, and then you have like maybe this one sentence in a document that contains information, what can be like a Word document and a spreadsheet, a God knows what. From a infrastructure perspective, what's hard? What do you go like, this is like, maybe the answer is everything at this scale, but what's hard? What is like really challenging at this scale?
Well, okay, so it's a good question. We think of it in actually 3 levels that are, and each has their own set of challenges. So the first is like the core infrastructure level, which is kind of the thing you asked about in the beginning, which is how number of files, number of objects, number of blobs, number of records in a database. How do we handle the massive amounts of activity and analysis? At some point we might have 1 million interactions happening at any given second, and then we have to keep track and log and maintain all those in addition to update things, ensure reliability and so on. So just the infrastructure level at scale is a huge challenge. Like when you're talking like exabyte scale or trillions of things happening, millions per second kind of thing, there's just a fundamental reliability distributed system scale. And so that's something that we both build a lot of capabilities ourselves, in addition to using the latest techniques in the world, the best databases, the best sort of everything out there. So that there's a whole sort of big part of our Box engineering team is dedicated to doing that well. And then the second level, which is where a lot of the very hard challenges are around the idea that for Box, one of the things you do is you can just share with anybody. And so even though we have all this stuff, it's critical that when you look at your Box, you only see that one little sliver. And you can then easily share with something or with another person, another company, another anything. And we all secured, all make sure you have the appropriate rules, the appropriate security policies. We have things like classification policies. This is confidential. These are the rules, what you can do with that kind of confidential thing, and so on. So these are all the idea of what we call our core platform, content platform, which is the idea of representing everything as collaborative content. When you're dealing with like large scale infrastructure, like a lot of enterprise companies will be like, oh yeah, we have that problem. Yeah. And so, you have to deal with tenants. You have to think about them all separately because most SaaS products are inherently a multi-tenant system. But with Box, one of our challenges is everybody shares with everybody, right? So you go into this, you have this challenge where like somebody from customer A is sharing with somebody from customer B, and so you can't actually separate out the content explicitly, like by fully tenants per customer. Because let's say that Bob, like you're in your Box account and you share something with me at Box, like or at another company, then you would say like when I do a search, I need to find that content you shared it with me. So we have to like inherently go through and look through all these different systems. So you can't just cut things off per enterprise. So this idea of a multi-tenant like capability across our content, across our preview, across our search, across our AI, like those kind of things are actually the really hard challenge, because it starts to fundamentally break down the simplicity of doing these like individual items on a shard of data. And then the third piece is also another fun topic, which is AI, because for AI, one of the things that we focus on is to not only do secure large scale infrastructure, collaboration permissions and so on, but then also allow you to do AI securely at scale. And so then we have to then have AI respecting its permissions. Like you should never want to have AI be able to answer a question on a content that you don't have access to. Right, so that's just like kind of built in. In addition to, we want to bring all the capabilities safely and securely of, if you want to use like Gemini or OpenAI or Anthropic or all the different models. And then so at that level, we have to be able to quickly follow the industry. There's a new model every week, it seems, and that is the new model is like the greatest AI that's ever been created in the history of civilization, and we have to support that immediately, safely and securely, respecting permissions and so on. So that AI level is actually itself an infrastructure distributed system content challenge. Those three things are very much on our mind every day, is to make sure we're very good at doing all these, because we are inherently the unstructured content platform that does all these capabilities for our enterprise customers.
Yeah, and before going to the AI thing, because I really want to set up, because we're running, of course, in infrastructure company as well. The size we're at is not like the scale of Box yet, right? But we already see like all these challenges that come with these tiny nitty gritty details, right? But if you roll them out of all your customers, and it grows quickly. And I could imagine that with AI, you're adding this whole new way of of course, when you deal with the models, with vectorization, with vector embeddings and that kind of stuff. And then you have to go like, oh boy, now we have to do this at that same scale again. And help me. So what I actually don't know is, are you operating you're partly operating own data centers, right, and partly public cloud, right? Or is that one or the other now? How do you think about that?
Yeah. We're 100% in hyperscaler public clouds today. So if you look on our website, you'd see it would tell you that AWS, GCP, Azure, IBM, the sort of the biggest of and the most reliable, trustworthy public cloud vendors. We use a variety, so we're multi-cloud from that aspect.
Yeah. So how do you? And this is really for you as like question for you in your role as like CTO at this scale, right? How do you think? So what are the considerations, and maybe you can even tie that to AI, right? So if you would go through that exercise, how do we build that up? What are we going to rent? What are we going to? What kind of things, especially when it comes to models and those kind of things, impact those decisions on the scale that you're operating at? How do you think about it from a CTO perspective?
Yeah. So I'll kind of almost highlight it in the terms of those layers. And so from an infrastructure perspective, one of the things about having a very large number and high percentage of Fortune 1000 companies is that many times they have strong preferences. And so like most, maybe 10 years ago is different, but like these days, I haven't met an enterprise company who says, I don't use one of those hyperscale providers I provided. Almost all of them, AWS, GCP, or whatever it is. Like they prefer them. And sometimes they really strongly prefer them. And then and so we've historically been in a spot where we can cater to the preferences of some of our customers. And so and this is why we were inherently multi-cloud. It wasn't just because we wanted our own infrastructure level flexibility, but because it's inherently quite hard to do multi-cloud. But we also wanted the ability to cater in some cases to some specific preferences of our customers who felt strongly about the trustworthiness or the capabilities of a specific vendor. And then this is also what helped us move from a data center oriented system that we had years ago to a fully public cloud based system. And so we kind of inherently have thought through this in the past and have like the ability to switch regions, switch zones, switch providers, and so on for certain classes of our content, or certain classes of our infrastructure and platform. And then now on the AI world, it's the same thing where people have very strong preferences in some cases about their models. And there's two reasons for that. One is just the same preferences that they had. Some people just really love, let's just say like AWS's Anthropic, which is AWS is great, Anthropic is great. So that's it. That's a great model that they prefer. In addition to the idea that sometimes they just say, I don't want other things. And so, and then with AI, of course, the model quality matters a lot, and it changes like all the time. Like I mean, just the other day I tried GPT 3.5 Turbo, which was the model that kind of started the whole revolution of like, wow, this is amazing what computers can do and what AI can do. Generative AI is a term now. And going back to it, it's like this was like almost unusable for the kind of use cases that we care about today. And then now it's like, is GPT 4.1 is totally great. Gemini 2.5 is really great. Anthropic 3.7, and so they're all kind of one-upping each other almost daily. And some people don't realize the progress of all these models. So for us, for our enterprises, for our customers, our goal will be to use all of them and to then help customers make these decisions by what we just choose, but then always to give the model choice to the customers when they want to build their own AI agents, when they want to just say, I prefer this vendor over another one. And this actually provides a challenge. And this is the platform AI level that we have, which is we need to support these things immediately. We need to give our customers an indication of the quality for the kind of use cases that Box does on unstructured content. And then again, always with safety, permissions, security in mind, so that you don't, by moving fast, we don't accidentally create like a data leakage event. And this is just built into all levels of our Box platform.
And thank you. And I have one more question just to set the scene, right? Because of this scale and that I just find it fascinating. So one thing that I find also just super interesting, and this is also a question for you really in your role as CTO is like, so your CEO, so Aaron, right? So your boss, he's of course very vocal also on podcasts and those kind of things about the role and the importance of AI. However, you also keep emphasizing when you talk about AI, and then you say, and then comma, of course, security, yada yada, etc., that kind of stuff. How in a like a big company like Box, right, a public company like Box, and you as CTO, and then it's amazing that you have a CEO who drives that vision. How does that enable you? So if other people are listening who work for like a large company like Box, how does the things that Aaron is saying, the CEO is saying, how is that enabling the tech side of the house? And how would you not be enabled if that vision wouldn't have been driven by the CEO like he's doing?
Yeah, it's. I think it's a good question that's particularly relevant for many companies today, considering the sort of the technology disruption that's happening in the background. And so for me, if you looked at my history, you'd see I started my career in a very small company that grew up. We got acquired by IBM. I spent time in IBM. Then I started my own company again, and then I got acquired in a Box. And so in that world, I sort of fortunate enough to live in tiny companies, just like in our house, kind of companies. In addition to very, IBM's been around for 100 plus years, I think, or a very long time, and operates at a scale that is sort of very wide in variety of how it approaches the world. So you start to see these difference between the founder-led companies, between companies that are growing, between companies that are mature. And so, and they all have benefits and they all have challenges. And some people are like, I'm a small company person or a big company person. And I think what they're saying is essentially that they prefer some specific types of challenges to others. Like in a bigger company, you have challenges of alignment, you have challenges of getting everybody on the same page, getting sort of the gears of the company turning. In a small company, you just have challenges of you have to do everything yourself, and you have to you don't have a base to build on. Everything's a little bit more fragile. So to answer your question, at Box, what we tried to do, and one of the great things about a founder-led company with somebody like Aaron, who is in the details and sort of like passionate still after so long, is that we almost have I hope in one of the we try to maintain the idea of the best of both worlds of a startup driven culture and a startup driven mentality of doing things that are like new and interesting and innovative, while also maintaining the sort of the processes, the system that will make sure that we don't, moving fast can break things. There are certain things that are okay to break. There are not other things that absolutely can't. Like we do not compromise on data security. We do not compromise on reliability. We do not compromise on sort of the fundamentals of promises to our customers, not only as a matter of technology and product and sort of mentality, but also as a matter of compliance, as a matter of our contractual commitments and so on. So you have to balance these things. It's very hard. In my opinion, and it's a thing that is why you see some companies struggle to take advantage of the latest AI or any capability, because it's if you're running a business, it's hard to keep up with the fact that the newest model completely changed the world, and it went from 2.0 to 2.5, and suddenly that was the thing that then enabled you to do all this new stuff. And so you have to have up and down level of commitment to it. But then also not just everyone in the company worry about AI, but let's make sure that we focus our efforts into something that is targeted. I'm a big fan, and one of my passions and one of my jobs is to build everything as a platform level. So even though it's changing, it's still platform oriented, so that you can build on top of it, and it has reliable ways it works. And so those are the kinds of things that we worry about in terms of when we're thinking about these kind of founder versus large company kind of thought process.
I see. Oh, this is so insightful. And with this, this kind of gives like a mental picture of like at the scale, and we set the scene, and now you're enabled and slowly starting to dive into the tech. You mentioned 10 years, right? Or 9 years at the company.
I think I just hit my 10 year. Yeah.
Yeah. And so coincidentally, I started my journey with embeddings 10 years ago. It was purely by coincidence.
And kudos to you. 10 years ago, I don't embeddings was not a word that most people recognize like they do today. So I've always appreciated that about you and your background, is how you have lived through this before it was cool. You know about embeddings and vector databases and everything else before it was a household technology name.
Well, I mean, it was hard to explain to people why it was cool that you could, calculate the distance between banana and tennis shoe. But that is kind of how it started, right? So that kind of evolved into, of course, because of transformers and those kind of things, and in that these embeddings that they started to play a role. And in the beginning we thought they were like magic, right? That they could do everything, and of course they couldn't, right? So and then for the people listening, is like we could capture the semantic meaning, but we also needed traditional keyword based matching, and that's nowadays we merge that together, and that in Weaviate we call hybrid search. And that turned into this first milestone, which was this specific database where the core feature was around the vector index with everything around that. That was step number one, right? So we had these high quality embeddings database. Out of that, what started to emerge was hey, people started to do a RAG, and of course you can use any data source for RAG. But one of the nice things with the combining semantic search with RAG was you of course didn't know what the input question would be. So that embedding played a great role in trying to do the candidate selection and RAG. And then out of that, we got the agent. So how I like to visualize it, that I always said, I have like a dot, and I say vector database, and I have a dot of a vector database and a generative model, and an arrow. So we have RAG, and then we have the same thing, an arrow going back, and then we have an agent, right? So what was the moment, if you look back, that maybe even before we called it AI and still machine learning, or maybe it was after that tipping point of AI, that you were like, was that with the vector embeddings and vectorization that you saw opportunity for the documents, or was that later more with the generative models? What was the first moment that you were like, we need this?
Well, so in our world of unstructured content, these are each one thing you mentioned is a very critical concept, right? Because in the past, like we've been support. If you look at our website and our history, like we've been supporting AI and ML for a long time. We typically use the word ML before 2022, but now it's all about AI. And this is an important moment, which is it used to be you'd have to train a model to do whatever you wanted, right? So I have a contract and I want to extract details from it. This is important to me. This is an important business process. I have this unstructured content. I need to structure it. So we support it, but we'd be like, we need to find a model that works or train a model that works. And of the exabytes of data of the trillion things, typically that was only a tiny little bit. Now it's an important bit, but it was like 0.01% kind of thing. And so you start to find yourself having to train these different models. So interesting sort of revelation number one, which is amazing, which is the P in GPT, right? The pre-trained aspect of it, which is that you don't need a new model. And then also a great part of the generative AI is that it is also understanding AI, right? Like you can, the things you tell it, it will immediately turn around and be able to like parse and analyze for you. It's like a wonderful sort of byproduct of the way that this like kind of technology works. And so once you have a pre-trained generative model that's fairly capable, and of course the models these days are like, you could call them college trained or even PhD level in some cases. Like they know a lot, and so they deduce things very well. They're very and then for an enterprise now, this is awesome because you're able to go in and like do cool stuff. But without access to your data, then it's almost like I have the smartest person in the world in my company. They're going to do this great stuff. But then it's like, oh, but I'm not going to let them access anything. They can't read the email. They can't like see their data. They can't look at presentations. They can't go get research. Like, and then he's like, all right, well, that person's not necessarily going to be as impactful as they could unless if they had access to your enterprise data sources, which take multiple forms, right? Like your structured data, your CRM data, your all the different things that company uses, and most of data in a company is unstructured, is content, is like what we focus on every day in Box. And so with this AI now, this is like a gift for us because we were like, you can actually process almost anything. It's amazing. It's almost like the mental model that we think about and we talk about is imagine that you had a smart person who's like, you're looking at your content and then you're like, hey, I have this question. It's like, well, I just read it and I'll tell you the answer. Or let me go look through it and I can do it really fast and I'll tell you the answers to these things. So you're getting insights in your data, structuring unstructured data. This is the kind of thing that works really well. So, okay, but all of it, if you sit back, you're like, well, wait a minute. How is it going to get that access? It can't read everything in real time. And you absolutely don't want to train it because it changes constantly, right? Like, hey, we're working on this project or whatever, and then things are being updated. Somebody puts something somewhere, they remove it. They you can't train. Not only is it too expensive, but it's too slow. And so what do? You look it up. So you look it up, you retrieve it. The retrieval augmented generation is fundamental to enterprise use of AI. And so to your question on embeddings, like embeddings, I think is the unsung hero of the AI revolution, in particular for the enterprise. I saw something recently, because we've been talking about RAG for years, and I saw somebody say, oh, because the context windows are so big on an AI model, RAG is almost like not needed anymore, right? But no, I mean, like I don't, it maybe in certain use cases, but whoever said that had a misunderstanding of the benefits of RAG in the enterprise, in my opinion, because you need to get the latest data, and the latest data changes constantly, and then you need to then turn around and then give the model this. Here's the latest data, and very critically, what you have access to. And the AI should never have access to anything that you don't have access to, and then turn around and generate the answer for you. So, long way to say, RAG and embeddings are absolutely critical to most things that I perceive to be enterprise class use cases on their internal data.
Yeah, and I really want to double click on that context window thingy, but there's one more question that I have related. So everything you just explained, if we would plot that on a timeline, right? I want to go all the way to the beginning, right? So I could imagine, so like for example, right? So let's take a completely different piece of technology just to make my point, right? So let's say, you hear people talk about, like back in the day, they talk about like blockchain and that kind of stuff. And then you as CTO, you read in that because you see like, hey, distributed data, what is that? Is that something for us? Yes, no. And then you do whatever you want with that, right? So if we talk about machine learning and AI, if we go back to that moment, can you remember what was it maybe that you read or that you saw or or maybe somebody in your team showed, or what was the moment that you were like, oh yes,
Yeah.
this is gonna? Do you know when that was and what it was that you
Yeah.
saw?
So we saw and because we've kept up over time over the latest of the natural language understanding of how it works, and so we were always interested in the latest sort of like you might consider like GPT-2 class of models, and so when you see it, we were excited but then you would try it on things that people might use and you'd be like, it's kind of not ready. And so whenever, and this is the challenge of the enterprise or just for any product development in AI, is that it's a totally awesome concept until you hit something that doesn't work very well. And then like your excitement level just plummets. And so if you hit six things that are awesome and one thing that's not good, you're like, okay, but if you hit like first thing you try doesn't work, or if out of 10, four don't work, like then suddenly you are like, I'll wait. And so we constantly were experiencing this, like, oh, there's some flashes of brilliance, but like if it was an employee, it would be like one that you were hoping, like continues to mature and continues to learn more, so that it's able to do more kind of better work. In the meantime, you can't give them critical tasks. Now, when ChatGPT came out, and in particular when the GPT 3 or 3.5 became available via API in a trustworthy way that was production class, that was the moment when you then started to not only see the quality get there, but then also not just a research project, not just something that you kind of like play with on the side, but you could actually power AI on content in a way that our enterprise class customers would say, this is actually something worthwhile. So then you start to see things like processing, like doing retrieval inside of a document, across documents, on a corpus of data, being able to do things like powering your kind of search, being able to find facts for you, needle in a haystack style. And in that moment, when you try some of those things and you're like, I can't believe this thing figured out this crazy document and this crazy question and then put it together and gave a really good answer. Like that's kind of amazing. And that moment probably, somewhere around September, October, like right around when ChatGPT was launched in 2022, like is the moment where you're like, this is actually going to be the thing that is not just a neat little feature, but something that is we need to think of as redefining our business. So compared to your old question, like we say this all the time internally. Aaron says this constantly. If we were founded today, how would we use AI as part of our platform? And as an unstructured content company, like of course, AI would be the central piece of the whole thing. And that's how we think about retrofitting everything to be able to provide AI, again, on the benefits we have, safety, security, distributed infrastructure, and so on.
Yeah, and this is super interesting. And this is kind of it's interesting to actually to double click on that because and relate that back to the embedding. So because one thing that we know is that for the foreseeable future, dealing with these models and representing data, we're going to use embeddings for that, right? So they play a crucial role. And that is, for example, what you said about the context window. What I always say is like, well, it's like if you actually look what's happening in a context window, is like, you have a word. If we talk about an LLM, you have a word, gets turned into a token gets represented by by vector embedding. So a context window is basically an array of vector embeddings. And
Yep.
for those, what I did myself, and for those who are interested in it, like if you look at the Hugging Face library, you can actually see it, right? Because it's open source. And if we want to reliably store that kind of stuff, we call that a database or a database management system. So it's like you see my point. So properly storing things, we call it database management systems, and the things we refer to now are vector embedding. So if they're stored in the context window or to represent something, that's just it's hard for me to see that change in the near future. But
Yeah.
I find extremely interesting, and this is really going also, Connor. This is going more on your terrain and expertise. But of course, when we started with these kind of things, right? And we took, for example, take just a text document, for example. We started with just indexing a text document like with one embedding, and it was like, oh, so because if the document was too, of course, that was too long, right? So and then we got like the chunking strategies and those kind of things, but I think now, even if we look at now, and you know more about this than I do, Connor, but if you look at Colbert and those kind of things, we even use multiple embeddings to represent a single document or part of a document. So maybe also a question for you, Connor. What do you think is the most, if we look at one document that would be stored in a box, right? What would be the most optimal way with today's cutting edge models to chunk it or to store it? What do you think is the most optimal way of doing it?
Well, I think with Colbert, it's really interesting for like long content. Like you mentioned, the chunking strategies, and we had this history of, you have a massive PDF, and so you break it up into these 500 token chunks. But now we have a great way to represent, just represent this long context with a bunch of embeddings and have this kind of late interaction scoring thing. So sorry, Bob, I'm not super sure what the question is, but the question of like how much data per object is that?
Yeah, exactly. So what I'm trying to get to is that, because I'm trying to make it very like atomic, like just a single document or maybe even a single paragraph, and then I want to bring that back later to the scale that Box is operating at, because we're gonna deal with infrastructure questions around that, right? So because I think if we take just a let's take a one pager, right? Just a one pager. The we on average, how many embeddings might we use to properly represent the one pager with, like, let's say 5 paragraphs or something? Would it just be
I'll
5?
give you
Yeah,
the box approach if you're interested. So
yeah, yes, of course, yeah.
this is an ongoing challenge that we're constantly optimizing. So the things you're asking about are just like very relevant, because and it's interesting the way you phrase it, because sometimes people care about the file. I need to find that PowerPoint presentation that talked about something. I need to find the research paper that did blah. I need to find the internal project plan of blah. And in that case, you kind of are thinking it holistically about like finding content. At the same time, half the time, or some large percent of the time, you actually care about the answer, like so that data inside the file. And I think people historically in enterprise class systems didn't differentiate these, because you always had to go find the thing and then as a human read it, because otherwise you couldn't understand it or watch it or see it or all these other things. And so then this actually translates directly into your embedding strategy, because if you want to have people find information, you need an embedding that captures that information. So you can imagine, like, let's say an earnings report or something, long unstructured data. But if you say, like, what is the revenue or the risks associated with this company or whatever, you got to go find that paragraph or that page. And so you need embeddings that are able to support the idea of the per paragraph level. So this is how we think about it: is that first of all, we need to store we need to chunk at a level of the way the documents are organized to be able to properly represent the information inside of them. But then also, at a higher level, some people they need to find that document and then turn around and be able to share it. And you realize if you're not careful, then you end up with too many embeddings, like too small of chunks that either miss context or completely blow the cost of this whole thing out the water, because many times the embeddings are actually longer and more than the actual text that you have.
Exactly. That's where I want to go with this question. Basically, it's like that is why I'm so fascinated by the scale that you guys are operating at, because if you have a use case with 1 million documents,
Yep.
right? Just random number.
Yep.
And you go like, we're gonna be very nitty gritty about the embeddings. We're gonna be very creative, and you know what? We end up with like 10x, right? So it's like we have 10 million embeddings to represent 1 million documents.
Yeah.
If you do that at the box
more.
scale, yeah. If you do that at the box scale, I mean, or you maybe you guys did something very innovative, or I don't know, but that's gonna be expensive. To generate these embeddings, to store them, to search them. So how help us think through, how do you deal with this at the box scale, right? So it's like, how do you do that?
So you it's challenging is the shortest answer, because you not only have to handle the getting users exactly what they want, but then also multiply it on scale. And when you're talking about something like search, it's like not okay to just do it on a small little bit. You have to do it on lots of things. So you have to find techniques that work well, but also don't basically put you out of business because it costs you too much, right? And so the very first time we were like, oh, well, let's just calculate paragraph level embeddings on the whole corpus of data and do that. And then you think about that for a while, and you're like, wait a minute, that would cost you more if you're naive about it than then all customers pay us for the last 3 years. And of course, you don't do that as a public company or as any reasonable company, I suppose. And so instead, you start to look for ways to optimize these things. So there's a variety of techniques that are constantly be adjusted internally, doing things like making sure that we calculate embeddings for specific purposes, like to the point of, is this an embedding that indicates what the file is about versus an embedding that indicates like a paragraph inside of it? Also, at some point, pre-calculating everything is not necessarily required if you can quickly do it in real time. So in some cases, what you can do is look up some info about that gets you in the right direction. So, you have access to like 2 million files or something in your box count in a reasonable company. And then we'll do a query, get quickly access to a smaller amount of them that you care about from your query, and then go through and maybe calculate per paragraph only on a smaller subset that you looked up using other techniques, including keyword search, including some higher level like file level embedding, and those kind of things are sort of the techniques that we use to make sure that we don't completely destroy our infrastructure budget and again put ourselves out of business because we got too carried away with the cool technology.
Yeah, but this is super interesting because I think people. I mean, we see that, of course, with Weaviate users and Weaviate customers, and is that the bigger these use cases become, people start to ask these questions. It's like, we started with just generating embeddings for everything, great, and now we're scaling up, and we go and we're looking at our bills, and we go oh boy. So
customers are doing it too. Like a lot of the first thing a lot of big companies do, they're sophisticated, was they're like, I'll just index all my data, or I'll get a partner to index all my data, and then at some point you're like, yeah, that company has 30 petabytes. Are you sure you want to index all that?
Exactly.
The bill will IPOP for anyone on that one.
Exactly. So are you saying that just in a if I understood it correctly, like on a very basic, in a nutshell level, it's like the retrieval of the right information and what is indexed when? So is it like indexed and is the embedding stored in the vector database for like all the time of, let's say, those 2 million documents, and then you're also doing some on the fly stuff based on the candidate selection that's coming out of a vector space, basically. Do I understand that correctly? How does that architecture, how is that chunked up? How does that work? What steps are involved there?
Yeah, and to highlight, it's an ongoing set that the new techniques are emerging constantly, including ones we come up with, industry level technologies and so on, and including some of the cool stuff that you guys build is very cool. But at a high level, sort of step one is to cut down the recall set. So again, you have a million files you have access to, and if you're a reasonable person at an enterprise, shared drives, your own stuff, things you have. And so step one will be to find a way to get a smaller set. And to the extent that you have embeddings pre-calculated ahead of time, wonderful. If you have metadata that we've extracted ahead of time on important documents that have structured data about it's a contract and what's the effective date, who's the employees, and so on. Like there's a series of techniques that would be either traditional search, traditional query, traditional embeddings, traditional being the last 3 years. These are things that you do to step one to get a smaller set. And then at some point, the set becomes small enough that by parallelizing properly, by sort of in some cases, even doing the cool new techniques are like intelligently, like having AI kind of look through the set and be like, I think this one's better than this one. Like then we call that deep search, and that's a really interesting area. But then you can then cut it down to a set that you then can then do a more sophisticated and expensive analysis on a subset of data. So I can't remember the details about the latest state of the art from the way that we do it, but I think you can do, if you're talking about pages of a document, you can do hundreds or even maybe thousands of pages per second of embeddings calculations, in which case, then if you get I think that these 10 documents or these 1,000 pages or whatever you want to think about, these slides or pictures or whatever are relevant, then you can then calculate those and then get a better answer inside of that or that set. And then I think for most companies, this has to be the way they deal it, because again, even a new company, a new startup that's like, just growing or whatever, like at some point, even storing the embeddings, the bill for that will be more than what your customers want to pay you for that service. And nobody's, in the long term going to want to do this at a loss. And so you have to have these kind of techniques.
Yeah, this might be an interesting. So people listening might find this interesting. Actually, if I may quickly share this anecdote from a Weaviate perspective, so these vector indices, they started in memory, right? So because that's the fastest, that was where most of the research was coming from. But we literally sold this with our customers. That people at some point were like, "We're very happy, but we're growing fast. This is getting very expensive, right?" And that was also how the flat index and the what we sometimes refer to that also as warm storage was born. That we saw like these certain how people deal with tenants and storing the kind of information, that doing that based on disk and with cache and those kind of things was actually for certain use cases better. So that's very nice to see the evolvement of the database with how the market was maturing, because just doing all that stuff in memory, that at some point that's just it just doesn't, you can't just justify it at some point anymore. And that was like, we, thanks to our, actually also the open source community and our customers, we learned like, hey, we need to have different indices for different types of use cases to support that. So this my point is what you just said really resonates, because we've seen that like firsthand. But one of the things that I would
on your point for a moment, it is shocking when you make the realization that sometimes your embeddings are longer than the original data. So like if you do, let's say you do a paragraph and there's a few sentences, let's just say it's, I don't know, a few hundred characters, so a few hundred bytes. What's a long embedding in your world? How many bytes would it be?
How many bytes? Oh, I don't know, but it's like I think that the I'm trying to think how to chunk this, right? So, but if you look at an embedding of like 1,500 something embeddings, and that's then also those are floating points. That's a handful of kilobytes right there, right?
So is it? I'm trying to remember the data. Like, so is it 4 byte? What is it? 4 bytes in a floating point these days, or what's the underlying representation? I forget. So, but it's somewhere. Yeah. Like let's just say that you have 1,500 embeddings. Is it somewhere between 1,500 bytes and maybe 6,000 bytes or something? So I'm taking 100 characters that I have to store, because you have to store that, and then I have to look up and I have to also store the embedding of 6,000. That's a giant, let's just say an order of magnitude or two greater than what you had. And so, like to the point of the scale that we're talking about is like, you don't want to have, your data at an exabyte scale, and I guess we says, not megabyte, not gigabyte, not terabyte, not petabyte, but exabyte, and then have exabytes of these embeddings. That's just like, you don't do that. And so then you have to find like interesting techniques. So I remember being shocked that the biggest bill for our in embeddings was not the cost of calculating embeddings, but to store the embeddings in an easy lookup way. So then you get down to the infrastructure challenges of the sort of the lower level we talked about in the beginning, which is like, you probably need a way to have different storage classes to store these in a way that makes it retrievable, like in a way that is reasonable. And without that, like, again, like you just end up with this challenge of you can't use these techniques at scale on enterprise class data because it just grows too much and it's just too expensive. And again, nobody will want to pay for that.
Yeah, this is super interesting, because you're basically, any chunk that you're indexing, you're basically adding, what is it, 4 to 6 kilobytes.
Yeah, I mean, and to the point, like
on everything.
You don't do that at scale. You find a new technique to not do that at scale, because then like it won't work. Like you can't stand it.
That's an excellent point. And again, we've seen that firsthand, where people are asking like, we need more engineering and more ideas to solve this problem, because we love the use case, but at some point it just, we can't justify those billions of embeddings in memory. And I want to make this jump, because if the search techniques and which of course we could talk for another hour about this stuff, but I really want to get to the the next step as well, and that's the agents, right? So because I really see this as an evolution, I think Connor, of course, you wrote an amazing blog post. I mean, I don't know how old that is now, but about back then that we talked about the generative feedback loops, right? That we said is that like a year ago or more even, maybe, right?
Yeah, I have a 2-year birthday cake for it.
Oh my God. So 2 years ago, we were already thinking about this, right? That we said like, hey, if we do something out of a generative model, we can just, put it back into the database, and then that turned out, of course, in our case, into the agents, which, by the way, are for people listening, you can now use them in Box as well. So in combination with Weaviate, so that was I'm very proud of that. That very cool release. But the how do you look at that? Because the thing that I always like to say, so we have like 3 types of agents. We have the query agent, which, what's in the name, right, helps you to query stuff, and then we have the transformation agent, and the transformation agent takes it even a step further, where you basically, it can now transform data for you if you want to, based on the information. And we have the personalization database agent. Personally, I always say I'm the most excited about the transformation agent, because, as I always like to say, it really feels that for the first time in history, we're able to turn chicken shit into chicken salad. That is always what I like to say when it comes to working with data, because we now have an agent.
Advice for you to work on your analogies on this one. I'm not sure that's the sales pitch that most places. I don't think you see that anywhere. So.
No, but just for the podcast. No, but okay. This is podcast language, right? So it's a but on a serious note, I really think this is for the first time that we can have the models help us deal with the garbage in problem, right?
Yeah. And so
yes, and I would love for you to talk about that.
So for me, like, it's one of these like fun discussions. Like, we can even go in immediately and just start talking about agents. And most, like, even our customers across board, one of the things we do is we just dive into talking about agents, even though the term agent itself can be defined differently depending on who you are. And it's almost like a fun CTO topic, is like, what makes an agent versus not, and like, how are the subclasses of agents and how do you define them? And so I'll stay away from the full variety of that. Because interesting. All right. Or we can do another. I'll come back at some point if you want to talk through what makes an agent, like, and the 6 attributes of the agent, or 12, depending on how you look at it. And so but for us in Box, to solve that, like, one of the things we try not to be too pedantic about what is an agent or not, but basically anything that's an objective-driven, intelligent thing that you're interacting with that has some sort of agency in the agent world, like, then can do things for you. And then the idea of AI agents are that they can do more and more complex things. So we sort of think of them as like levels of AI agents, similar to your scale. I think of like, they can do this, and that gets more complex. It can do this more transformational, which is more of a more complicated agent. So to the heart of it, I think if you looked up AI agents in Google Trends, you see this funny thing. It's like in the last few months, or in the last 6 months, I guess. And then why? And it's because everybody is seeing that to make like the full promise of AI, it needs to do more and more complex things, not just simply a one-shot respond to this, which is great at, but also do more, think more, process more. So the idea of time and the idea of more tools to then let you go look up or cause actions, that's where you start to see some of the value. And so in my whole world is enterprise focused. So in this world, it's like, back-end processes, automating things that used to require like the worst part of like some people will say like, this thing I do, please find a way to automate this because I hate it so much, and everybody does, and it takes all our time. We can't do the other things that are more important for our jobs. And so like those kind of things are where we see that AI agents can work on. And it used to be that we'd have workflow tools and we'd have these, maybe like robotic process automation to do certain things, but it was also like the fundamental unit of what they could do was relatively weak. It was like basic. But then when you kind of couple the idea of an AI model, like current technology AI model, and then just kind of add the idea that you're going to string together a series of steps, either that the AI planned for or that you told it to do step 1, then 2, then 3, then suddenly you see these almost like much more complex, but also much more valuable sets of work that they can do for you. So we kind of envision in the future that like it'll just be normal to say things like, my team of agents are doing this work for me, or you perceive yourself working with agents, like it's like your coworkers almost, or your team, and that will just be common. Like and so then like us at Box, in addition to like our integration partners or customers, this is just we're just building towards this future at all times, so that we're prepared for helping people kind of do the work on things like their unstructured content.
Yeah, and would you go as far as saying that you think that the agents, especially when it comes to the not only querying information that's stored in a box, but also the generating content, because there must be a logic
Yeah.
behind what people store, right? So if you have like every month a new financial review or something, we could imagine that at some point an agent says like, I'll take care of it, or just I'll write the first template or something.
Yeah, it's actually like exactly as you said. Like oftentimes, one of the things you want to do is to process and query and gain insights of content, and then do a bunch of work on it, and then spit out something else. And so for Box, we have these fundamental capabilities of being able to understand content via AI, but then also create content via what we call DocGen. And so then there's an a fun example that we've been playing with. So this is not yet released, but we've talked about it publicly. Is RFPs. So anybody who's worked in like sales or like something like and kind of wide variety of companies, is like somebody comes to you and they're like, here's 1,000 questions about weirdly phrased and according to my industry, like answer all these and then maybe you'll get a deal. So normally this is like you get your, some of your best people and they go through, engineers or others, kind of like answer all these esoteric questions. And then you get somebody else to go through it and like be like, oh no, you phrased it wrong. Let me be like, and then look for discrepancies. And so sometimes it's like a process of like 10 people for like, many hours. Right. And so, and then people put them in these repositories. And so step one of this is like, I want to get access to the data that is there. So we have this capability where you do retrieval augmented generation across files. We call it hubs. And so we saw that people were putting all their RFPs into these hubs, and then they would go, like a person would go and they would like copy out the question, put it into the like RFP history, and they would come back. Here's the answer, and they copy the answer back. And then so you see these people who are quite valuable, who had a lot to do, who were just copy pasting back and forth, and then like editing the responses. And so then this is like the idea of an agent. You're like, well, hold on, like why not have an agent do that step? Get the questions, ask them, and they get the answers. And so just the fact that they could look up the answers would cut it down from like 10 hours to like an hour. But they still had to copy back and forth. So, but then you get an agent to like start to do that for you. And then they're like, okay, great. I can get it all in one spot and then I can edit it. You're like, well, some of the editing you're doing is straightforward, like make sure the tone is polite, make sure you're always like positive how you answer, make sure that like, and then so you can have, again, add another step, have the AI agent go through and do that. They're good at this stuff. And then so at the end, like you then have this like, okay, well, and my little agent does all this and it has this list of things for me. And it's like, well, now I got to put it back in the document. Like that alone is kind of a pain, right? Like I copy paste it. Like, so then why not have the AI generate a new document that has all that? Like, and so this is to me like a small example of something where there's like 1,000 examples of this kind of process in every company, where people are doing this kind of stuff all the time. It's expensive. And again, I've never talked to anybody, and I've done a lot of these RFPs where they're like, I'm so excited to do this RFP tonight because it's so great. Instead, usually they like to be the last person who's reviews it. They're like, I'll look to make sure it's right, and that you made instead of being the one who like fills in every detail. So this is like my AI agents or my agent or the team of them, or however you want to think about it, does that work for me. Then that is just a great way for me to focus on making sure this is a great RFP. But all of the copy pasting back and forth, looking up the basics, like that's just done. And so, this never before in the history of enterprise software or any technology was it possible to do something this complex. But now with AI agents, it's not only possible, but it is sort of possible in a way that will meet some of the enterprise class ways. There's still work to do to make sure that it's like really easy to use and can be customizable and so on. But this kind of thing is exactly what I believe the promise of AI agents bring to especially the enterprise.
Yeah, that's fantastic. And I also want to emphasize that there's of course the database agents that we have, the Weaviate database agents, that now we have that also that box integration. And I've seen even some community members already write some blog posts on how they played around with them, how they integrated them. So we're not talking science fiction here. You can actually try to start to work on these things already with your own data. So, and that's I think that's quite exciting. So, I think also a bit. So I think we're a bit at time, Connor, aren't we? Or but this was really great, and it's like I think, especially from how we started from the the size of Box as a company and how you work as CTO also together with CEO, and then the skill how you think about these architectures. I think that is extremely interesting because everybody who's going to build these kind of AI applications, this kind of skill, has to at some point think about this, and then ending with the agents. This was great, man. I thank you so much. I really appreciated it.
I enjoyed the conversation. Looking forward to coming back and talking about some of the subtopics someday.
Yeah, and then I'll work on my analogies.
Exactly.
Thank you.